Alright, you geniuses, so today we are looking at differentiation again and finding the equation of a tangent at a particular point on a curve. Now, let's just think about what this means. Here's a curve, a y equals x squared curve, and there's a point here, and I want to know what the equation of the tangent is. Well, you know that a tangent is a line that touches at just that point. Obviously, I haven't drawn this very well. So how would we find that? Well, it's going to be a straight line. It's going to be y equals mx plus c. What we can do is we can find the gradient using the dy dx, and the c can be found by inserting the point that we know, the coordinates of the point. So that's essentially what we're doing today. Now I'm going to do a couple from here, so I might do number 1a. First of all, I'm going to go dy dx, so I should get 2x, so I'm taking that 2, multiplying it by the coefficient of the x. Then same with the next one, it's 2x to the power of 1, so I'm going to get minus 2, and that would be that because the 1 drops out. Now that means I can find the gradient at 2 comma minus 1, and that's going to be, I'm going to insert this 2 into the x value here, so that will give me 2 times 2 minus 2, which is equal to 2. So the gradient is 2. Now I've got m is this, and I've got my 2 points, so I'm going to go y minus y1 equals m into x minus x1, which is our equation of a line. So y minus y1, that's this bit here, so minus minus 1 equals m, which is 2, into x minus, and my point is at 2. So we get y plus 1 equals 2x minus 4. So y is equal to 2x minus 5. And that would be the equation of the tangent to that point. Now I'm going to do one more. I'm going to do b. First of all, I'm going to go dy dx again. So this will be 3x squared minus 5. So 3 times the 1 is 3, drop the power down. 1 times the minus 5 is minus 5, and drop the power down, so it'll become x to the 0, which means the x drops out. Now, gradient, whoops, change colors, gradient at 1 comma minus 7 is equal to 3 times 1 squared minus 5. Now, that is equal to 3 minus 5 minus 2. Okie dokie. Now, we're going to use y minus y1 equals m into x minus x1. Now, what do we know here? Well, we know that y is minus 7, so it's going to be y minus minus 7, right, that's this point here, is equal to minus 2. So minus 2 into x minus 1, because 1 is up here. And then we just work this out. Y plus 7 is equal to negative 2x plus 2. And so y is equal to negative 2x minus 5. Okay, so that's that one. Now let's try something a little bit more complicated further on in the exercise. This time we have an equation, and it passes through point P, and we've got to find the equation of the tangent. Now, exactly the same process applies. So 8a, we've got dy dx, and this will give us 8x squared minus 8x. Now, it passes through the point P at 2 comma 5. So gradient at 2 comma 5, we're going to chuck in that 2 for the x values there. So it's going to be 8 times 2 squared minus 8 times 2. Now, what does this give us? We get 32 subtract 16, so it should be, is that 16? I think the gradient is 16. Oh, you Larry. Look, I've just noticed what I've done here. It should be a 6. I need 3 times 2, not 2 to the power of 3. So that should be 6. And then I think everything else is right. So what we'll do is just pop that there and change that over. So it should be 6. Now, I was going to say, I was looking a bit iffy. Okay, 6 times 4, 24. And then we've got 24, take away 16, so 8. So our gradient is 8. I think we're okay now. Now, we also have this point, so we can do y minus y1, which is 5, equals 8 into x minus x1. And let's put that all together. 8x minus 16 plus 5. So I think it should be y equals 8x minus 11. And that is the first answer. Now, moving on to part B. For part B, we want to know where the tangent meets the curve again. So what we do is we go, here's our curve. We make it equal to the line. Is that right? That's what we want to do. Yes. So 2x cubed minus 4x squared plus 5 equals 8x minus 11. Bring everything across to one side. And then we can divide everything by 2. And what can we do here? This is not something I've taught you, but what I think we could do is if you use the table function, you can find some solutions. So if you go to the table mode of your calculator and type in this equation, x cubed minus 2 times x squared minus 4 times x plus 8, and then you go and press equals, and then start from, say, something like minus 5 and go to positive 5 and step up 1 each time, and hopefully in here there may be a solution. Yeah, so I'm seeing two solutions within this range. One of the solutions is x equals 2. Hang on. Yeah, when x equals 2. Or when x equals minus 2. Okay? So that would be how I'd solve this. I know it's a bit tricky, hey? Now we already know that P is here. So the other place that it meets is here at minus 2. Now we want to find the coordinates of that point. So all we need to do to find the y value is pop this in to our line equation here. So y equals 8 times negative 2 minus 11, which is equal to negative 16 minus 11, so negative 27. So it should be minus 2 comma minus 27. Okay, the tangent at the point Q, so this is another thing, the tangent at the point Q is parallel to the tangent at P. In other words, it has the same gradient. Find the coordinates of Q. So we want a gradient of 8. How are we going to get a gradient of 8? Well, 6x squared minus 8x has to be equal to 8. Now, you did this all the way up here, and you popped in a 2 to get a gradient of 8. Now, how else could we get a gradient of 8? Well, we're going to solve this. We're going to go 6x squared minus 8x minus 8 is equal to 0. And what we will do now is divide everything out by 2, so we get 3x squared minus 4x minus 4 is equal to 0. Now, what can we do here to, maybe we can factorize. Well, let's say we did minus 2 and then plus 2 here. I think that would work for us. Let's see, 3x squared minus 6x plus, yes. Okay, this is correct. So x is equal to 2, or in the first bracket, negative 2 over 3. Now, we've already got the point P, which is at 2, so it must be this one here. Now, we've got to find the coordinates of Q, so we're going to take our original equation, which is this one here, and put that 2/3 in it to find the y. So, let's do that now. Y is equal to, now what is the equation? 2x cubed minus 4x equals 2 times negative 2 over 3 cubed minus 4 into negative 2 over 3 squared. What else have we got? Plus 5. Now what does this give us? Well, when we chuck it in, what do we get? 4 times bracket negative 2 over 3 bracket to the power of 3 minus 4 times 4 over 9, I guess, plus 5, and I'm getting a value of 55 over 27 for y. So my coordinates would be negative 2/3, comma 55 over 27, and that would be all for that one. Well, I hope this makes sense. Let me know if you're having any difficulties. Take care.